Stop right there, kids. It's time for math with Mrs. Lehman. You've been pulled over for speeding through your homework. We're going to go over that today. Welcome, everybody. I'm here in my 6th period class. Say hello, everyone. They're so sweet. We are going to go over the homework from the other day, which was forever ago. They had a nice long weekend for Columbus Day. But we're on page 68, so we're going to go over this. Before we go through each problem, I'm going to do a quick review for anybody who is watching this at home, and obviously for the kids in class right now. This is not the right page. This is the homework for tonight, so we're going to go backwards. Thank you, Riley. We are going to this page. This is page 68. They look eerily similar. Okay. Everyone's on 68. You had to go through each problem and assess what the situation is. You had to figure out, what have I been given? What do I need to find? Okay? Talking about distance, rate, and time. So we were either calculating the distance or we were calculating the rate. Okay? They gave us the distance formula. Distance equals rate times time. So you had the option of using that formula if you're looking for distance, or the rate formula. Another word for rate when we're talking about distance and time is what? Speed. Very good. Speed. So when it asks who is faster or how fast something is, we are looking for the rate of speed. And you find that by taking your distance and dividing it by your time. Okay? So we're going to go through this starting with question 84. So you had to underline a few things. It says if Adam's plane traveled at a constant speed of 375 miles per hour for 6 hours, how far did the plane travel? So I'm going to ask my class, who can tell me one thing I need to underline here? Cam?
375 miles per hour.
Per hour, very good. We hear the word per, so we know that we've just been given the what?
Rate?
The rate. So I want everyone to look at their paper and see, did you label that R for rate? All right, what else should I underline there, Aiden?
6 hours.
Beautiful. 6 hours, and that's a measurement of
Time.
time. Nice. So we're going to label that T, and then we have to find how far the plane traveled, which would be a measurement of what, Joey? Very good. So we're going to label that D. So we are looking to find the distance. So which formula would we use here? Which formula? Brianna?
Multiplication.
We're going to use the one with multiplication, which says distance equals rate times time. So one mistake that I've seen kids make is they're rushing and they're not putting down the formula. Okay? Distance equals rate times time should be on your paper. Now we're going to plug in what we know. What do I plug in for the rate? Yep, Brianna just said 375 miles per hour times the time, which was what, everybody?
6 hours.
6 hours, good. When you multiply those two numbers, what should you have on your homework?
2,250 miles.
Very good. 2,250 miles. Nice job, Michael. All right. Make sure you have your label on there. A lot of kids left that out. And you said for every, so that's like saying that was for every 6 hours. So make sure you get rid of that, okay? All right. Nice job. Who here got that one correct? All right. Pretty good turnout on that. All right. Let's look at the next one. It says a salt marsh harvest mouse ran a 360 centimeter straight course race in 9 seconds. How fast did it run? What can I underline there? Jonathan?
360 centimeters.
Very good. And that would be our what, Jonathan? Jonathan just threw his voice to the other side of the room. Just kidding. So 360 centimeters is our distance. What else can I underline? Christoph?
9 seconds.
Very good. That's a measurement of
The rate.
Give your per in there. Time. Very good. So 9 seconds is time. I'm going to label that T. And it asks for how fast did it run. What would we label that, Victoria?
You would label. What was the question?
Would we label that distance, rate, or time?
Rate.
Final answer?
Rate.
Rate, very good. If you're looking for the speed, how fast it ran, that is the rate. So which formula should I write? Again, we have two options here. We can use distance equals rate times time or rate equals distance over time. What would that be, Stephanie? Very good. Not distance. Did you say wait? This is where editing would come in handy. Rewind. You're going to say something different. All right, go ahead.
Rate equals distance over time.
Very good. And now I'm going to say, yeah. Woo-hoo. Okay. One of these days, I'm going to learn how to edit these videos, and it's going to be wonderful. Until then, you're just stuck with this. Sorry. All right. Rate equals distance over time. We're going to plug in our distance, which was 360. We're going to divide that by our 9 seconds. And when we take 360 and divide it by 9, what do we get? 360 divided by 9. Michael?
40.
40, yeah. 36 divided by 9 is 4, right? And then you're going to throw that 0 on the end. And what would the unit be if we just took centimeters and divided it by seconds? Riley?
Centimeters per second.
Very good. When you are asked for the rate, you should have a per in there. So 40 centimeters per second. All right. Pretty fast little mouse. Well, we have another mouse who apparently is completing a different little race, and it says, another salt marsh harvest mouse took 7 seconds to run a 350 centimeter race. How fast did it run? What would I label the 7 seconds, everyone? 350 centimeters. And how fast? Rate. We're looking for our rate, so I'm going to use R equals
Distance over time.
distance over time. Very good. So 350 over or divided by 7 is what? What's 350 divided by 7? 50. Yep, 50. And what unit would I have? Who can tell me that? What unit? Cam?
50 centimeters per second.
Very good. Centimeters per second. All right. Any questions thus far? You guys feeling okay about this? Yeah. Okay. So the question is going to give you some info, and then you have to decide what it's asking you, okay? And then your job is to determine which formula will work to solve that. All right, Brianna? So you had two options. Sometimes kids pick the wrong one because they were racing through this. They didn't say, oh, R, I need to use the other formula, okay? All right, a slow boat to China travels at a constant speed of 17.25 miles per hour. What would that be when we hear the word per, everybody? Rate, very good. 200 hours would be our time. How far would be our distance? Very good. If you don't have these things on your paper, I expect that you're fixing these, okay? Let's see. So I want to find the distance. Who can tell me the formula for distance? Formula for distance. Emma, did you want to tell us?
Distance equals rate and time.
Very good. Rate times time. That little dot there means times time. So let me write that down. Distance equals rate times time. We're now going to plug into this formula. So we have a rate of 17.25 and a time of 200 hours. I did not put the dot for multiplication here because there's a decimal point right here, and you don't want too many. Like sometimes I think it's better when you have decimals to use these parentheses because you don't want too many dots, and you want to make sure it's very clear what's a decimal point and what isn't. All right, so again, different fancy outfit that multiplication sometimes wears. We are going to multiply these two numbers. All right. You guys know that when you have this, we can just do what at the end here? Yep, add zeros, all right? So 2 times 5 is? 10. Carry your 1. 2 times 2 is? 4. Plus 1 is? 2 times 7? 14. Carry your 1. 2 times 1 is? 2. Plus 1 is? 3. Now, there's a trick to this. What do I have to do with that decimal point? If anyone tells me that you have to just bring it down, I'm going to have to scream. Jacob.
You count the number of spaces it is in the number.
Very good. So in your multiplication problem, in this right here, you're going to count the total number of decimal places. In this case, we have 1, 2 total. You know, if there were a decimal place in this bottom number, we'd include that in our count as well. So it's 2 over, so you're going to start with the decimal place at the end here and move it over 2. So your answer would be 3,450. And what unit would that be for how far the boat traveled? Tori?
Miles.
Miles, very good. So we're actually just going to skip 88, and 89 was not a question that you guys had for your homework. Okay, actually, we probably should go over this one, shouldn't we? Yeah, we should go over it. All right, rewind the tape. We're going to talk about 110 mph. mph stands for miles per hour. That's a rate. Very good. 2.5 hours is a time, and how far is our distance? You guys are great. All right, we want to find the distance. So distance equals rate times time. We're going to plug in 110 and 2.5. So you could keep that as a fraction. Personally, I like to work with decimals a little bit more, so I'm going to change it to 2.5. Did you guys know that that's the decimal equivalent of 2.5? Okay, 0.5. All right, so we are going to multiply 110 times 2.5. So 5 times 0 is 0, 5 times 1 is 5, 5 times 1 is 5. Put a 0 placeholder. 2 times 0 is 0, 2 times 1 is 2, and 2 times 1 is 2. Oh, this multiplication is so difficult. All right, 0 and 0 is 0, 5 plus 0 is 5, 5 plus 2 is 7, and 2. Now, how many decimal places do I go over? 1. There's a total of 1. So that would be 275, and it's asking how far. Our distance would be 275 miles. Yep. All right, any questions on that? Okay, so 89 was not a question on your homework, so if everybody could please go ahead and read that, underline the key parts, label the key parts, choose which formula will work for this question, and then plug in. I'll come around and check answers. I'm going to pause the video while the students work, and then we'll go over it together. Okay, so the kids have already said that the formula, some kids said it, that the formula is rate equals distance divided by time, or you may hear people say over time, which means the same thing. All right, so we need to plug in the correct info here. So let's go through our question. It says a world-class marathon runner can finish 26.2 miles. So 26.2 miles would be our what? Distance, rate, or time? Distance. All right, 2 hours is our time, and we're looking to find the rate. All right, so that's why we use the rate formula. Okay, we're going to plug in what on the top. What number goes on top? Michael?
26.2.
Very good. 26.2 miles. And our time on the bottom? Hold on, Emma. Hold on, I'm coming over to Emma.
2 hours.
2 hours. Very good. And when we take 26.2 and split it in 2, what would we get for every single hour, Riley?
13.1.
Very good. Yep, 13.1. And it was looking for the rate of speed. So what would our unit be there? Our rate unit, I should say.
13.1 miles per hour.
Very good. Miles per hour, and some people might even write it like this, mph, which is perfectly fine. Okay? Any questions? Okay. Number 990 has an interesting twist. It says banana slugs can move at 17 centimeters per minute. All right, let's underline that. 17 centimeters per minute would be our what?
Rate.
Our rate. So we're going to label that R. And it says if a banana slug travels for 5 hours, hours would be our time. How far will it travel, which would be our distance. Now, some kids aren't going to be paying attention, and they're going to get trapped. There is a trick in this question. So I want everyone to read through it and figure out if you can find the trap. After a minute of careful reflection, Jacob has a trick. What is the trick here?
They say 17 centimeters per minute, but they're in the second part. They're telling us 5 hours, not minutes.
Very good. Our units are not matching. That's a big problem. All right. So we have two choices here. We can either figure out what the banana slug's rate is in terms of hours, right? Or we can figure out how many minutes are in 5 hours. Okay? So we can do it both ways. I'll show you both ways actually. So either way, we're looking for our distance, right? And our distance equals rate times our time. Now, if we want to stick with 17 centimeters for 1 minute, right, that's fine, but now we want to have the 5 hours in terms of minutes. So we have to figure out how many minutes are in 5 hours. How many minutes are in 5 hours, Stephanie? 300, very good, because 5 hours times 60 minutes each would be 300. So 17 times 300. And that means that the little banana slug would go how far when you multiply that out?
5,100
Very good. And our unit would be what?
centimeters.
Nope, not per, just centimeters.
Oh.
It's a distance. Good job, Michael. So 5,100 centimeters. Some people are going to look at this a little differently. They're going to say distance equals rate times time. And they're going to say, well, my time's in hours, right? So they're going to want to put their rate in terms of hours. So if it's 17 centimeters for 1 minute, how would I figure out how many centimeters this guy would go per hour? Huh? All right, so if we know 17 centimeters is in 1 minute, I want to figure out how many minutes. How many minutes are in an hour? 60. So what do you think I have to do with the 17 and the 60? Not divide it by multiply. Because this is just 1 minute, right? Because it says per minute, that means for 1 minute. So 17 times 60 is going to tell us how many centimeters this slug can move in 1 hour or per hour. So 6 times 7 is 42. 6 times 1 is 6 plus 4 is 10. So some people are going to put that as their answer because they're speeding through math, okay? That's why I pulled you guys over. The rate would be 1,020, and we could write this right here. It's 17 centimeters per minute, or 1,020 centimeters per hour. Now we can use our 5 hours. So if you go ahead and multiply those two, what do you get? What do you get when you multiply those? What do you get?
5,100.
Very good, 5,100. So, centimeters, very good. You need to make that decision. Do you want to convert your centimeters per minute to centimeters per hour, or do you want to convert your hours to minutes? One of the two. You have either option. Okay? But that was a trick. I warned you guys before about making sure your units match. That would be a classic example where kids just multiply 5 times 17, and they say that's their answer, and they definitely get it wrong. Because that for sure would be on a multiple choice question. That would be the trick answer. Okay? We are going to go to our homework because this is kind of more of the same. We're going to go to lesson 23's homework on page 72. I'm going to give you a little hint here. These questions ask you to find the rate. So we're going to say rate equals distance over time, okay? So, for example, in question 91, it says, who walks at a faster rate? So we're looking for the higher rate here. The person who walks 60 feet, that's our distance, in 10 seconds, which is our time, right? So we've got to find out what that person's rate is. So we're going to say rate equals distance over time. We're going to say, what for our distance? 60, and our time is 10. So what's 60 divided by 10? 6. So this person's walking 6 feet per second. We are going to compare that with this other person who does 42 feet in 6 seconds. Right? So again, rate equals distance over time, and they're going 42 feet. It's taking them 6 seconds. When you divide 42 by 6, what do you get, Stephanie? 7, and that would be feet per second. So which person is faster? The person who's doing 60 feet in 10 seconds or the person who's doing 42 feet in 6 seconds? Christoph? Which one? I can't. 60 feet in 10. They're only going 6 feet in 1 second. This person's going 7 feet in 1 second. So who's faster? It'd be this guy, right? Because he or she's going 7 feet in 1 second. So they're going further in the same amount of time. That's faster. Okay? So that would be a faster rate. So you would say the person who walks 42 feet in 6 seconds is, excuse me, is faster. Okay, I'm going to assign the homework at this point. I'd like to thank everybody for watching. If you have any suggestions on editing YouTube videos, please comment below. Don't forget to like and subscribe, and have a great day.